Question 17. P on this diagram represents the complex number Z. We're also given that W is the complex number cis 2 pi by 3. For part A, we're told that Z is equal to R cis theta. We're asked to find WZ and W bar Z in polar form. If W is cis 2 pi by 3, then W bar must be cis negative 2 pi by 3. Remember, a complex number and its conjugate will always be reflections of each other in the real axis. So WZ would be, multiply this and this, and we get R cis theta plus 2 pi by 3. And then for W bar Z, we multiply this and this, and we get R cis theta minus 2 pi by 3. In part B, we're asked to explain why it is that the modulus of OP is equal to the modulus of OQ, which is equal to the modulus of OR. All of these three have a modulus of R. Perhaps you should note that the modulus of cis theta for any angle is always 1. Since they all have a modulus of R, they will all lie on a circle, center at O, and of radius R. Now in part C, we're asked to show that the complex number representing the point M is negative a half Z. If we consider the vector OQ and the vector OR, our knowledge of vectors tells us that OM is equal to a half of OQ plus a half of OR. So that's a half of WZ plus W bar Z. Now, WZ is this expression, but it's best to write it as R cis theta cis 2 pi by 3. With W bar Z, we get R cis theta cis negative 2 pi by 3. So that gives us, taking out the common R cis theta, remember R cis theta is Z, so that's a half Z. Then in here we've got cis 2 pi by 3 plus cis negative 2 pi by 3. So that's a half Z. This is cos 2 pi by 3 plus I sine 2 pi by 3. Then we have cos negative 2 pi by 3 plus I sine negative 2 pi by 3. We know that cosine is an even function, So cos 2 pi by 3 is the same as cos of negative 2 pi by 3, so that's 2 cos 2 pi by 3. On the other hand, the sine of negative 2 pi by 3 is negative sine 2 pi by 3. So the sines will cancel. The cos of 2 pi by 3 you should know is negative a half, times this 2 gives us negative 1. So we're left with negative a half z. There are other ways of getting this result, although they are related. For example, one idea that I tried was taking the fact that Q would have coordinates r cos theta plus 2 pi by 3 and r sine theta plus 2 pi by 3, and that r would have coordinates r cos theta minus 2 pi by 3 and r sine theta minus 2 pi by 3. We can then find m, which is the midpoint, by averaging the coordinates, using expansions for cos of a plus b and sine a plus b. Cos a minus b and sine a minus b does give us the same result, but it is quite a lot of work for 2 marks. Finally, in part D, we're told that S is chosen so that this is a parallelogram, and we want to find the complex number represented by S in terms of Z. This really isn't very much work for 3 marks, because we know that this is Z, we know that this is negative a half Z, so PM is equal to minus 3 over 2Z. That has to be equal to MS if this is a parallelogram. So we're at negative a half Z here. Take away another 1.5 just gives us negative 2Z.